Hello. So we're going to talk about Rust a bit. Not the same kind of talk that Alejandro gave yesterday, but more looking back at what we learned when working on the Rust guest tools and what could be improved, what practice we can try to make better, and what we could push various communities to do to improve things. So the driving the thread that we'll follow in the talk is mostly about the Xen guest agent, which was the first Rust project that we worked on, and that's quite a small one. So we still have less than 1,000 lines of code for the project itself. It has still a bit of characteristics that you don't find in every Rust project, like specific code and use of native libraries, and that counts. We also had another project which has XCP metrics, which has different runtime environment constraints, because the agent is meant to run in the guest. So we have this multi-platform constraint. And for XCP metrics, the goal is to run in the DOM0, so we have less constraints, and that's different. So that's why it's the agent which drives that talk. So the first question that could be asked is why we selected Rust in the first place. I won't get into details about the advantages of the language, but the fact that it's a very useful language and that there is a huge community of developers, and that could be a way to make the Xen project more appealing to new people that don't necessarily want to just stick with C and experiment with Rust, and etc. So what did it look like? First, we wrote it as a prototype to learn lots of things. But in fact, there is a huge amount of library crates in the Rust lingo that already help us to collect lots of info. So that we are a bit forced in some way to use external libraries, much more than we would do in C. Well, we'll come back on that later. So the essential information we collect, we don't really necessarily have to implement lots of things. Same for publishing the information. We had a few choices to export information through XenStore. We selected the XenStore OS crate, which is a wrapper around the C library. So we know that has a few drawbacks, but that was likely the shortest path. That was a small project with a French maintainer that we know, so that helps getting contact and getting things forward. So for a prototype, it was not much of a problem. And once Alejandro's work is more advanced, I think that would be a good fit for moving forward. And then we had to find a design to get a code base that is maintainable and still able to support the various different aspects of the different guest OSs, since on Linux or on FreeBSD or even on Windows, you don't use the same APIs to get the same information, or even to export through XenStore. So we had all of the libraries, but like that often happens, they were not completely fitting our needs, so we had to interact with the community, with various maintainers, to extend the libraries. So for XenStore OS, we had some contact with Mathieu Taral, and that went quite smoothly. When we came to FreeBSD support, there was some difficulty, because on Linux to fetch changes in the network configuration, you have netlink, you can just listen for events, and on many other OSs, you don't have netlink, especially on FreeBSD. On older versions, which were current versions at the time, you did not have netlink, and the way to get notified of network event was not easily accessible programmatically. But luckily, they starting to implement netlink in FreeBSD 13.2. But then no one knows that netlink is available in FreeBSD unless you tell them. That's the case of the libc crate, which is the glue that translates all the constants we have in the libc header files into Rust constants. So that's a really low-level crate with lots of manual things you have to copy-paste. And so we had to teach libc that FreeBSD had netlink support, and the netlink crate had to be extended, because there are lots of assumptions about when you have netlink. Basically, when you're on Linux, you have netlink and you have these and these features, but on FreeBSD, they implemented just for now a subset of what we have on Linux. So it was not just a matter of telling, okay, netlink is there. There are quite of filtering to do. Oh, I'm not used to that. Okay. So let's talk about Rust now. In the Rust community, you will always hear that Rust is a young language, and that's an excuse for a number of things. Okay, I'll leave you judge as to if it's still young after 10 years, nearly 10 years after 1.0, but well, that's another question. So the fact that it's young, it's used for an excuse to have no stable ABI. So shared libraries are a bit of a problem. I'll dive into details a bit later, like that. They have a really fast release cycle. You have a new tool chain release every 6 weeks with new features. So that's great. There are lots of new things to do, so not a problem. Except for support, maybe. But we'll do that later as well. Another big thing that's a big change from C and especially C, C++, etc., is that you have, when you take Rust, you have cargo as well. So cargo, that's at the same time a build tool like make, project description tool, something like CMake does, but also doesn't make the build files. That's right. It's doing quite a number of things. Yeah, the package management as well, as we'll see. And there are very few projects in which you will not have to use cargo. So the Linux kernel is maybe the only example that I know about that they have a special environment, and they master the bits a bit more, because cargo, its main usage is basically to fetch all your dependencies, handling the versioning of dependencies, the compatibility of different versions, and so all of that, which is obviously not a good idea when you are dealing with a kernel. You want to have your own libraries anyway. So, getting into details in those points. The lack of stable ABI. So the first consequence is that you cannot distribute shared libs, because if your distribution would ship a shared lib from a Rust crate built with one version of the toolchain, you would not be able to link it with a program that would be built with a newer version of the toolchain. So that's a bit annoying. Can we find workaround for that? You can use a stable ABI by exporting a C ABI, basically. But then, okay, you build your Rust library, you install it on the system, you have the headers to go with it, and then to use it from another Rust program, you have to use it like a C library. So you don't have all the advantages that Rust brings you anymore. There is even a POC, proof of concept, that was done a few years ago, but never updated. The approach is not really nice anyway. So, okay, let's accept that we cannot distribute shared libs for now. Can we at least link with the shared stdlib, the standard library of Rust? After all, when you install the toolchain, you have single.so installed, that is the stdlib. Let's look at where we find it in Debian. Deep inside a Rust directory, not the friendliest place to place a library. That's clearly not really done for that. And if you try to do that, you have to use special flags, special build command to achieve that build. So can be done, but not comfortable. And so what does that mean for packaging Rust applications in various distributions? So I'm thinking Linux, but FreeBSD has the same problematics. So you can either stick to the old practice of packaging libraries in their own package. So that's what's still done by Debian and Fedora, for example. So there's a bit of work for that, since there are so many libraries. The granularity of the Rust crate is really a small granularity, so that translates into many crates. So a high maintenance load on the maintainers, and we'll see other problems later. Another approach is to use what they call a vendor tree. That's when you make your release, you run a command, cargo vendor, that just keeps a copy of every one of your dependencies in your source tree, and you ship that. So you can imagine that a small 1,000-line project becomes a multi-megabyte source tree. That will work. There will be some issues when we want to maintain that, update dependency for security. We'll talk about that later as well. And the other approach, what they took in FreeBSD is say, okay, I have my own source code and all those dependencies. Those are all the source files for my package. So you have a build file, make file, that references 150 packages instead of just one source archive. That works, but it's not much different from the vendor tree approach. No? Wrong button. Let's talk about the toolchain. So, as I said earlier, they are making a new release every 6 weeks. But that only support the latest version. As soon as a new version is out, you will not see any update, normally, of the oldest version. So it's a bit of a problem for the traditional distribution approach, where you ship one toolchain, and then you want to use it to build your packages. And when you have security updates, you can update your compiler, update your toolchain, but if you don't have any updates, that changes the constraints. What they do, what they tell when you talk about that is that newer releases are the updates to the older ones. Basically, they make every effort not to break compatibility. So in theory, you should be able to replace your current toolchain by a later supported one without any problem. Well, bug never happens, obviously. That allows them to have less maintenance work on the toolchain, but that's a bit pushing existing players into new paradigms. So, or they also have a way to introduce breaking features. Sometimes they have an addition mechanism where they can introduce breaking changes, but that's something that every application library author will opt in. So you should not get any breaking change unless you request for it. There are sometimes some discussions about getting LTS versions of the toolchain. There was one thread that was started not that long ago, in which I tried to participate. But basically, the first impression is that there is a huge pushback. People just don't want to, or many people don't want to maintain an LTS toolchain because they fear that it will split the effort. People will spend time maintaining an old version of the code that others don't care about, and it also splits the users because when you have an LTS, some users will be pushed to use the LTS and not use the latest version, and they rely on having a large user community on their latest version to have it, to make it stable, to find the bug early, etc. So it will need some good arguments to convince them. It will likely take some time. Maybe it will never happen. Maybe it will. But if you have some constraint to voice, don't hesitate to participate in the Rust forums on that discussions so that all voices can be heard. Let's get back to cargo. So the Rust community really like to have pure Rust things. So that's likely one of the driving reasons behind Cargo and other tools. That's a nice advantage for the user because you don't have to install thousands of tools. You install Rust, you have Cargo automatically, and you can even write some specialized build procedures in Rust instead of having a dedicated language like Makefile or Mason or whatever. But that comes with drawbacks, obviously, because when you start to implement a new tool for a problem that has already been solved or addressed in other places, you cannot hope to handle everything. So, for example, you don't even have an install target. So, with Cargo, you describe how to build a project, not how to install it. Anyway, you cannot really build libraries. We've seen that shared libraries are out of the picture for now. So we only build applications, and so, okay, it's not that hard to let the packager take the binary and install it where it wants it to be. But then, typical applications will come, for example, with data files. So you cannot describe that in your Cargo TOML file. That has to go somewhere else. If you don't want every packager to specify to where this file should go, where the file should go, you have to provide yourself some wrapper script, some makefile, etc., whatever, to finish the job. So, okay, they have something pure Rust, but that's just not sufficient. And if you have a project that's not fully 100% Rust, for example, you write a library, and as part of your project, you have your C library, and you write Rust bindings for your library. That still happens. You cannot build a C library from Cargo. So you have to have your build system for your C library, and, for example, you call Cargo from there. But then you don't have any interdetection of files to be rebuilt. You change your C library, you have to rebuild everything on the Rust side, or trigger that manually, or whatever. That's not clean in a project description approach aspect. There has been some attempts to use something else than Cargo. There is some support in Mason, for example, to build Rust packages, but then you don't have all the dependency handling that Cargo provides. So basically, very few people are using other tools than Cargo to build Rust. Cargo also has another aspect, which is dealing with dependencies. So you will declare for your dependencies with which version of them we are compatible. They're using semver for that, so you can express that one library will have breaking change in some version, just bump the major version, or that you will add new features, you bump the minor version, or it's just a bug fix one, and you bump the third component. So that's really nice. That we have something some source of information to trust about what to expect about which version of a crate. That's not perfect for lots of reasons. You can have breaking changes that will not affect many users of the crate. So sometimes you have major version bumps which force everyone to rebuild for just a small change. So there are approaches to deal with that, but that's out of scope here. But that's extra work anyway. That's a bit like the difference between the nice theory and what happens in practice. This versioning that makes it quite easy to make frequent releases and to make breaking releases. You just have to bump a number. So, okay, I have this idea, I'm making a new release. Anyway, I don't support the other one, so not a problem. And so you have some packages that are making frequent breaking changes. And when you have a project that has direct dependencies and indirect dependencies, that's an ecosystem with really fine granularity of packages. So you often end up with having several of your dependencies depending on different incompatible versions of a third dependency. So that's handled usually quite well, since if the library does not access a shared state or somewhat, something like that, you can have just 2 copies of 3 or 5 or 4 copies of a given dependency. That's a waste. That works. Sometimes you have big problems because 2 versions of the dependency have, especially when you use 2 versions of a dependency where the data structures will change. Sometimes you have surprises. For example, with the Windows WinSys crate, which evolves with a certain rhythm, and each release makes big API changes. Not every crate updates right away to the latest WinSys. And then you end up with a situation where you are forced to use that version because of that crate, and you would like to use a more recent version. Okay, Cargo will happily pull the 2 versions, but then there is some compatibility issue behind the scene, and you get some strange behaviors, some bugs, some things that remind us of the world before Rust, in fact. That's a bit hard. And I'm not sure there is an easy fix to this situation. So about the granularity, we have tons of packages available, and at one point you will start using, you or one of your dependencies will start to use one given crate because it provides a cool feature you don't want to re-implement. Sharing the difficulties is a good practice after all. But then people don't always stick around with those projects. So you have quite a number of orphan crates, and it's not that easy to hunt for them. So that leads us to more into supply chain domain. What would be really interesting is to be able to specify in one's project, I will have this policy about security maintenance. This branch will be security maintained until this date. Such kind of information, so that yourself as a developer, you write that in your cargo terminal or whatever, and you get some checks that all the libraries that you're using recursively will match the criteria, so that you are able to ensure to your users some kind of level of support. Try to throw the ID in the toolchain LTS thread. Oh, time is over. Well, basically that's complicated. Thanks, Nicole, for the idea about SPDX. That's, I think that could be in their scope. That looks like it's not yet, but thanks. I think that's something to dig. Let's go quickly. We have a new tool, which is Cargo Vet, which has the aim of sharing reviews of packages to help prevent some supply chain attacks by having big players or anyone. You can express that you have reviewed that version of the software and others can use them if they trust you, etc. Something that's really interesting. That does not solve everything, but that goes in the right direction. We have problems. So I talked about orphan crates. Even without going to crates that are orphan, some are obviously maintained by a small team. Problem that libc, crate that I already talked about, seems to be in that situation. I have a PR that's there for more than 1 year and still no answer as to if it will be merged one day or so. It's been scheduled, since there are breaking changes, it's scheduled for the next major release, which is bound to happen maybe sometime this year, maybe next year. We don't have visibility, and there are really, looks like there is one guy taking the decision and making the reviews, etc. So that might remind you of XZ, maybe. Well, we're a bit out of time, so though that's not really a new situation, the cargo with all those dependency trees, etc. That's something that has been handled in other places, in other ecosystems, but I think the big problem that the big blocker in the cargo world is just a lack of stable ABI and of shared library that just amplifies the problem. So let's say directly to that one. So we talk about security maintenance a bit. Just for a bit of numbers. For Xen guest agents, we have 19 direct dependencies. Some of them are optional depending on platforms, but well, that's a big number. Only 4 of them have stable APIs. And if we extend that to the indirect dependencies, 2/3 of them have no support, basically, other than just upgrading to the latest. So it's hard to security maintain a Rust trait. So sorry, it looks like we don't have much time for questions. So I'll be available around if you have some question to ask me. Thank you for your attention.